Welcome, everybody. Tonight is the 15th of March, 2022, at least in Dallas, Northern America. So this is Dallas Personal Robotics Group Robot Builders Night Virtual. And just another night chatting around the table of robot-y related things like we usually do. A little housekeeping, not really any change from last week that I'm aware of. But there is this reminder that we do have someone volunteer to present on the 9th of April. It turns out there's some kind of contest. I don't know the details, but on the 1st of April is the contest. And after the contest on the 9th of April, Jesse's going to talk about his entry, his solution for that contest, which is based on Oak Delight. So as a bunch of us have the Oak Delight, that should be pretty good. Anything? Oh, and Ray is reminding me that there's the Pate Swap Meet at the Texas Motor Speedway in late April, 28 to 30th. So if anybody likes old car-related stuff, there's many acres of that.
Carl, you got to go. You're in the old car biz now.
I'm planning to go.
Oh, are you?
Yeah, there's another convention in Florida the weekend before I'm going to too. But
wow.
And then, so then the other thing that's shown up is the Tyler Maker Fair, and I forget exactly when, but someone from the Maker Fair reached out, and I forwarded that to the distribution list. So it's a good show, apparently, from people who have gone, and if you're interested, just let everyone else know, and maybe there's a bunch that want to go. Having said that, I think we're ready to go around the table. We have in queue, we have David Ackley and Paul, and no one after Paul. So think about if you want to jump in after that. But without any further ado, Mr. Ackley, take it away. And you're muted. Microphone.
Okay.
There you go.
Yep. Okay, let's see. Present now. A window. Okay. Let's see. If I can get this. Share a window.
Can anyone else hear, or is it just me?
No, Dave, your voice is quite low. Quite low.
Okay, can you hear me now?
Yep,
That's better.
Okay. All right. I've been playing around with this TI IN 226, and a number of people are offering this module, and this module has typically a 0.2 ohm, a 10 ohm shunt resistor for measuring. And most of the documentation that people have out there talk about it measuring 3.2 amps. Well, that's fallacious. It turns out that with a 0.1 ohm resistor, that it would be 300 milliamps voltage if you had 3 amps. And if you look at the data sheet, here the first line, shunt voltage is limited to plus or minus basically 80 milliamps. 80 millivolts. So your range with that particular module, unless you change the resistor out, is actually 0.8 amps, not 3.2. So I just thought I'd point that out to people in case they're using that part.
I'm sorry, what, Dave, could you repeat what's the range again that it is versus advertised?
Well, they advertise it at 3.2 amps. Its actual range is 0.8. The reason is that with the voltage range here of plus or minus 80 millivolts with a 0.1 ohm resistor, that would limit it to 0.8 amps. I also confirmed this with the TI, and they said, yes, indeed, that's right. So if you get that module don't be surprised if you can't get to 3 amps. You'll need to change that resistor out, and basically you need to change it to a 25 milliohm instead of the 100 milliohm that it comes with. Just an FYI. That's all I had. Over now.
Oh, now you've got the Curiosity running. So, are you looking at this for a reason? Are you building a circuit that uses it?
Well, I'm gradually inching up on a robot, and I plan to use that to detect if the motor is installed.
Cool.
So could you explain a little bit what the purpose of this module is? I'm not familiar with it.
Okay,
Measure
this
current.
module lets you measure and report by I2C the voltage and the current of your supply, or whatever you have it hooked up to. And it's a fairly cheap module. I think it's about $1 on AliExpress, and it's up to, I don't know, $10 other places.
Okay, I could see use for that, sure.
So it does voltage and current, huh?
Yes. It measures voltage up to 36 volts, and current, it depends upon what you put in there as a shunt. And clearly the problem is that with the shunt that it comes, typically it doesn't have the range that you want. Now, if you use a 25 milliohm resistor there, it'll do the 3.2 amps, and it will measure to 1/10 of a milliamp is the resolution. And the voltage measurements are to 1.25 millivolts. So it's pretty powerful.
So Ted, I have to tell you, I've gone with a few of Mr. Ackley's recommendations in the past, and Dave, I have to say you got a keen eye for some cool parts in there. So,
Well, thank you.
nice tiny little parts with a lot of capability built in at a good price. So,
Yeah. I think the other current sensors don't measure voltage, right? They just measure current.
That's
Some of the
correct.
more popular ones.
Yep.
You got the best of both worlds.
Yes. And it's
and
very
it's on I2C.
Yeah, I2C.
So,
And cheap.
and cheap. It's a winner.
Where's Doug? He's got to know about that.
We'll let you pass it on to him.
It's in the notes. Very good. All right. Well, thank you, Dave. So let's see. Next we had Paul. Paul, what do you have this week?
So I've been quite busy this week, and I learned some things, and then I ran into some puzzles and some disappointing performance. So I want to share that with you. The first thing was I coded up a navigation by using Odometry based on David's slides. It's almost the exact same algorithm. Couple of minor tweaks where I found some things that didn't seem to be working, and one thing that I didn't seem to be working. So I'll show you that. But also got simulation reintegrated with the Mobot software. So I think you'll want to pin me to your screen so that my screen shows up. Is this showing up okay?
Yeah. Your voice is enough to override if the rest of us are quiet. So go ahead.
Okay.
Well, it doesn't show up as full screen though.
Oh. Then you got a different mode. So it all depends. Good advice, Paul. Pin the screen if you want it full screen. There's a little, if you hover over the middle of his image, it'll have a little push pin kind of a thing. And if you tap that, it'll make it full screen.
Is that in Google Meet or I'm using OBS Studio?
No, you're fine, Paul. It's a viewer side thing.
Oh, oh.
On the client
It
side
was
in our
my
browser.
problem, sorry.
That's right.
Okay.
Since we get to choose our own journey, there's so many different journeys you can take. It's hard to
Yeah.
explain sometimes.
Yeah. So this is the robot running. So I'm going to show the robot running in simulation, which shows both some behavior out of the David's algorithm that I didn't realize would happen, but it's clear once you see it happen. And then something that I really don't understand about the simulation. So this navodom.py is the program that takes a series of XY coordinates and navigates from one coordinate to the next. And so this is a 4-meter square. And so kick that off and send it on its way. And off he goes. And all looks good. The middle of the robot is right about where the round bit meets the square bit. So it actually overshoots by about like 5 centimeters. That's expected because it takes that long to slow down. And all looks good up through here. Oh, shoot. I meant to kick off a ROSBAG record. Well, I'm going to start that now.
Is everybody else's screen blurry?
A little bit.
Okay.
Well, it might be clearer to us if you would present rather than having us pin your little bitty screen.
Okay.
Blows up a low res.
Yeah, I think if you're using OBS and you're sharing it, you're treating your screen as a camera, it doesn't come through as clear as when you're sharing.
Oh, okay.
I know I've tried that. I've played around with that, but that's what happens. You're using OBS, right?
Yeah.
Yeah,
Well
you
done.
maybe-
And there's
That's
another
disappointing.
factor as well, because there's a setting where you can control your output broadcast resolution.
Right.
And it won't let you go to 1080p. I found it wants to stop around 720p, but those things, I agree with all those statements.
It's
So
might be clearer.
I think I won't do that for right now.
That's
Maybe.
weird. You've made it bigger.
So anyway, the thing I don't understand is that the robot here, it did its 4-meter square and it ended up, so it started right at 0, here and it ended up at some distance to the southeast of it. And looking at the pose, Gazebo tells me it's 24 centimeters to the right in positive in X, minus 29 negative in Y, which looks about right. But if I look at odometry, that is, it claims it's right on the money, almost. So I'm rather confused by that. I don't
29
understand.
centimeters is almost a foot, right?
Yeah, right.
Hmm.
So
You're saying it's overshooting a foot?
yeah, it's overshooting a foot, but Odom, which comes straight out of Gazebo, claims that the robot is at minus 2 centimeters in X, minus 5 centimeters in Y. So Odom is not accurately representing where the robot actually is. So that's my puzzle. I don't know how that could be. So anyway, but maybe I didn't want to dwell on that because I think there's the interesting discovery of how this algorithm works that I didn't realize can be seen. So I just recorded a bag file of the last half of the run. And so I'll pull that up and in the graphing tool, and if looking at and make some new graphs, and if I plot odometry, position X and Y over here, and plot them as an XY. This is the XY curve of the path of the robot. And what you see up here that's interesting is this little curve here where it starts to home in on the waypoint. And I didn't realize that would happen, but I put in some nav debug instrumentation like the bearing from David's algorithm, and you see here that the bearing as the robot approaches the waypoint, and I'll just pull over X distance. What I wanted was the command val was the target X and target Y. So I've used the same variable names as in David's code. So here, right at this transition, is where it goes from moving to from 0, 4 to 0, 0. And what's happening is, as it gets close to the waypoint, it's not pointing directly at the waypoint. And so the closer it gets, the more the bearing changes. And so consequently, it starts applying correction because the bearing exceeds the threshold for turning. And so what I see is this. So this is the angular component. So I'm using a fixed linear speed and fixed angular rate, except where it ramps down to a lower angular rate. But
the bottom screen is cut off. Can you move it up a little?
Yeah.
There you go.
And so here's where it rotated to point from the right to the left, and then it drove along for a little while. And then these spikes here are where it applied angular correction to compensate for, because it was detecting the bearing. So I set the bearing threshold. Like you've got that dead zone in there, David. I set that to 0.15 pi. To 0.15. So that's about I think 5 degrees or so. And as it gets closer, it sort of needs to bring in correction. You can see it got up to 0.17 there, and then it drops down to 0.08 because it gave it a little bit of a kick to the left. And then here's where the bearing, as it gets really close, the bearing goes way up, way through the roof. And what I found I needed to do was to put in a clamp to where if the robot was within the error circle, it didn't apply that that angular correction, because otherwise I found it would curve like it would almost loop around trying to get exactly on top of the waypoint. So I don't know if you've found that, if that's a known thing it should have, David.
Sorry, I had my mouth full. Um, let me back up a little bit. Because the algorithm uses a dead zone, that means when you're far away from the waypoint, you really have to be very, very close to directly ahead of the robot to be in the dead zone. But as you get closer and closer, obviously you could be just a few inches off, but if you're 90 degrees away, you're way out of the dead zone. That's actually what you want, because what it means is that the resolution of the steering goes up as you get closer and closer to the target. But if I understand what you're saying, you've turned that off. What that means is that once inside the error circle, the center of the robot is no longer trying to get over the waypoint. And then going back to the previous observation, you say that when it comes to a stop, it's nowhere near the center of the waypoint. So it seems like those two might somehow be related. But I can tell you, just depending on, what the maneuvering is getting to the waypoint, that often the robot makes little tiny corrections just as it gets to the waypoint in order to center, to put the center of the robot directly over the waypoint.
Okay. I was finding it was making big corrections, which was why I turned it off when it got close.
Big corrections.
Yeah, like it was
How
hitting
much?
90 degrees.
How much?
try and- Yeah,
90
when
degrees. That is a big correction. Okay, if it's off that much when it gets inside the error circle, then it seems like that it might have something to do with the steering to begin with. That maybe you're not.
Maybe my dead zone is too big, too wide, so that it's not accurately steering for the waypoint when it's a long way away.
No, I guess that's possible, but as you say, as you get closer, that accuracy goes up. I have to think about this a little bit. I'm trying to picture what could cause it to swing as much as 90 degrees.
Yeah.
I'll just have to ponder this.
Okay. Yeah. Any thoughts? I'd welcome them.
There's
So
Scott.
anyway,
Maybe Scott has some thoughts.
So anyway, that was an interesting discovery to see it actually kicking in some correction as it got closer, but not when it was a long way away. So so anyway, I think the exciting thing here was I debugged this navigate with odometry, waypoint navigation with odometry in simulation, and then took it to the robot on hardware.
Paul, does it do that overshoot when you go clockwise rather than counterclockwise?
It did the same thing. It does the same thing.
Well, if the wheelbase part of the calculation, if the wheelbase is wrong, if it's too large, then you go around 4 90-degree turns, and each one of those will be a little more than 90 degrees.
Right.
And so when they hit the endpoint, you'll overshoot the endpoint.
So an interesting thing was I ran the Borenstein, however you say his name, square calibration on the simulator, and when I run it with a program that just drives straight, then drives 90 degrees, then drives straight, then turns 90 degrees, then drives straight again, it actually is very close. It ends up within a couple of centimeters or less on a 4 meter square, on a 4 meter rectangle. So I think that it's calibrated correctly and works well when it's told to drive straight, then turn 90, then drive straight, then turn 90. What's throwing it for a loop is this dynamically homing in on the with a dead zone as it comes closer to the waypoint.
Paul, the purpose of the dead zone is to keep the robot from oscillating, swimming toward and so you might just make that as small as you can until the oscillations emerge.
Yeah, good idea. Okay, I'll do that. So then, thanks for that suggestion, David. So then after I got that odometry working, I thought, well, let's take Mobot outside and see how it does. So here's a video of that running that same program. And this is a 4 meters out and 4 meters back, 4 meters out and 4 meters back twice. So, and it actually didn't do too bad. It looked like it might have, it did pretty poorly when I ran the board. Oh, you saw it curve to the left there as it
Right.
was home in. So that's the behavior I'm talking about. And I think you'll see it. You might see it again on the return journey. It does 2 laps here. No, didn't do it there.
So the fact that it didn't do it means that it was accurately lined up. So it didn't have to do it.
Yeah. There's my wife out gardening. But there you saw it curve to try and reach the waypoint.
And it appeared to curve left and then back around, which is harder to explain.
Well, did I miss that? Is that what you're saying? That so because the dead zone, it's not going to have a small. If the steering correction needed is relatively small compared to the dead zone, it's just going to get way off until you get close. And then oh my golly, I missed it.
Maybe that's my problem. Maybe I've got my dead zone set too big. What do you have your dead zone set to, David? Or anyone?
I'll have to go look.
Okay. Then I thought, well, heck, and it did the Borenstein square circle outside pretty poorly, really. It ended up, a couple of feet away from its starting point. But I thought, let's see what it does on grass. So then the excitement really started. So and it was very disappointing. This is a 6 meters forward, 2 meters longitudinally, and it exhibited a strong tendency, a strong attraction towards the tree, the curb, the piles of mulch. So here it actually just squeezes by the tree and can actually rotate, but look at the wheels spin. Then it runs right into the tree, and then it skids its wheels and doesn't. So anyway, then you'll see it. If you look at that left wheel while it's trying to rotate 90 degrees, the left wheel is clearly skidding, and the robot only rotates about 45 degrees. And so then it runs on and it nearly runs off the curb.
Paul, you have to use a gyro outdoors or an IMU.
Yeah. Well, that's what I realized. This was a part of the learning was, so this is a 4 by 2 meter rectangle. That was part of the learning was odometry just is worthless on grass. It just ain't going to work. But so now Mobot is going to go in for some hardware upgrades, and I would appreciate any comments on the BN055 or any other gyros. But you can see the wheel spinning there on the grass. Interestingly, it turns poorly when driving forwards, but it actually will turn decently when going backwards.
But isn't the caster in the front?
Yes.
Well, there you go.
I don't really understand why that is. Why that makes it turn.
The robot's just going backwards. That's all.
So
it sounds like, Paul, that when you're trying to turn with the caster in the direction of the caster, that the caster is digging into the ground.
Yeah.
And
Something
when
like that.
So you're pushing the caster. That's why in general, it's better to put the caster in the back where you're pulling it rather than in the front where you're pushing it.
I knew I'd heard that advice from somewhere, and I figured it was probably from you. And so, yeah. So next up is doing algorithms to to make it turn. You could turn by doing a backing maneuver, at least for the majority of the turn.
Well, there's no reason.
Or
I
just
mean,
drive backwards.
yeah, with that particular robot, what's the front and what's the back is just an arbitrary decision you've made.
That's a good point.
Why don't you call the other end the front?
Is Mobot still in business? This may have been their downfall. I don't know.
Yeah, they are. They're on their fifth generation now. This is like
Oh, they
the
are.
second generation robot.
It'd be interesting to see if they've moved the customer.
No,
Or if they drive
well,
backwards. Yeah.
as of 2015, they hadn't because my neighbor's got one. But yeah, it's an interesting idea to just treat the back as the front.
Well, you don't have any sensors on it yet, so
I
Right.
think that
right.
the current ones have spiked wheels, which, Paul, I think that's one of the issues you're going to run into on grass is you don't really have a lot of traction surface. The drive wheels are very narrow. And I had that issue with Burp, and the original version of it had like bicycle width tires. And there just wasn't enough traction, wasn't enough surface traction to really grab, especially like on a hill. Your robot there was just on a flat surface, but the slickness of the grass and you just can't really get that much traction on it. So the Mobots that I've seen recently, I think there's one listed on Craigslist now. They actually have like a large chain gear looking device on the tire that actually kind of spikes into the grass. So apparently that may have been one of the things they tried to do with the traction issue. You were asking about dead zone earlier. It's only about 1 or 2 degrees dead zone on Burp. It's very, very tight. And like David was saying, it's really just meant to keep from oscillating back and forth. But I also have a PID on my steering algorithm. So any changes to the steering direction are dampened by the PID, which I can tune to make it, very smooth transitions from one to another. So that may be something else you might want to look at to really to dial in, because one of the things I saw with my CAN robot is as you're rotating, typically the IMUs or even the BN055 is fairly slow device as you're rotating around. So you almost always overshoot because the IMU is trying to catch up to where you're actually at that point in time, or the data coming from it. That's one thing I've seen. So I typically rotate very slowly, or the slower the better, because that way it'll get more accurate.
Scott, that's very interesting. I hadn't heard that before, but I have this older CH Robotics IMU, and when I first tried to pull the Euler angle, the yaw angle off to incorporate it in the odometry, I found that it was delayed considerably, not just one sample, but a number of samples behind where it needed to be. And that's why I eventually just gave up on the IMU. I went straight with integrating the Z-axis rate gyro. And that way I got the data that was synchronous with what was coming back from the wheels. I hadn't heard anybody else mention that specifically, but I did observe that.
Well, I just recently got from, I think it was SparkFun, there's a U-Blot new GPS radio that actually has inertial sensors built into it. So you actually get a yaw value or a heading value from it. I think you have to have some motion. I haven't really played with it that much. But I wanted to take a look at that and see because that's really from an AHARS or an IMU, really your yaw angle's about the only thing you really use. I mean, I know, David, you use yours for tilting and, if I'm falling over or something. And I've got a similar, information too, but it's really not that critical, right? The hardest part is knowing which direction you're going in a magnetic or, an absolute kind of direction. So if this new, and this thing's supposed to run at like, I think 100 Hertz or something, it's fairly fast, but again, I haven't really played with it. I just got it the other day. And
Can you put a link to that in the chat?
I can dig it up. I'll have to.
Is that the one that says it's intended for automotive use?
Yes.
Okay, yeah, I looked at that when I was deciding which one to get, and I ended up getting the straight RTK GPS rather than that one because there was some wording in there about how it's intended for vehicles, and if if you're not a vehicle, there were some characteristics that sounded like it might not work. I don't.
I
Well,
think it
the
didn't
way
work
I
that
read
well at low
that was that
speed.
it was fairly noise immune, environmentally immune, because I believe it integrates the GPS, the change in the GPS heading, or the GPS location, along with um, the sensors in there. I think there's an accelerometer and the magnetometer in there, I believe.
Right.
I have to dig up um, and it was, I mean, for GPS, it wasn't that expensive. I think it was 50, $60 for the little carrier board. So I'll have to find that ID, the part number, and post it.
I thought it was like more around the 300 level because that's about
Was
what
it?
the KGPS one is, and I thought that auto one was the same because it had RTK GPS. If we're talking about the same one from SparkFun,
Um, I have to look. I mean,
okay,
I'm kind of
okay,
talking off the cuff, so I
okay,
have to go
yeah,
back and look.
yeah. Well, thanks for the suggestions, guys. Some learnings and some interesting ideas. Um, Clearly, Mobot is going to get a hardware upgrade pronto to try and give it some better uh, navigation. But I'll look into that dead zone and see if that fixes my navigation problem. That's all I had.
I got a question. I got a question though that you've raised now. Thinking about this, so I want to ask about this dead zone thing. So if I understand, is the dead zone around the heading target? So
A
if as
circle.
long as the heading target is within a certain amount of degrees of the actual, then you don't apply any heading correction, right?
Correct.
Okay. So what makes me think about this is that when you first set the heading target, as long as like let's say your waypoint's up here and you're here, so when you first set the heading target, you're setting it way up there. So let's say you march off, but you're within the dead zone and you're like just underneath the dead zone. So when you first start to go, okay, no big deal. But as you go farther and farther and farther, your heading error is still within the dead zone, so you're still marching off in the same wrong direction, but your error from the path you're trying to be on is continuing to grow.
Yes, that's exactly what I was seeing, and what I was trying to point out was going on here. And David saying basically I don't have my dead zone tight enough, so early in the leg it's being allowed to run off too far to one direction or
But
the
it
other.
would actually be the other way around, Paul. That early on, that when you're a long way away from the waypoint, then it really doesn't matter. You could have a real wide dead zone. It's when you get up close that it starts to make a difference. If you think about the dead zone as a percentage of the distance from the target, so if you're 2 inches away from the target, but you're 90 degrees away, then the dead zone could be very, very large, and you'd be way outside of it. But
You'd
you
have to
should
think of
never.
it on a curve, right? The amount of correction, the closer you get, you're applying tighter and tighter tolerance to it, the closer to the waypoint. And you want to tighten that curve up, or loosen the curve up depending on what you're seeing. You want to start seeing, I would imagine, a correction sooner.
Well, but okay,
Right.
So,
I think
later.
Carl, if you can imagine for a moment that the dead zone is 0. So we just don't have a dead zone. So I
right.
just say if the target is to the right of the center line, I turn right. And if it's to the left of the center line, I turn left. The only time you'd ever go straight in a circumstances like that is if you just fortuitously happen to end up right on the line.
Which
That's not
never
going to
happened.
happen. What's going to happen is
Yeah.
you're going to be left and you'll turn back right and you'll cross over the line. And that'll cause you to turn back left and you'll cross over the line. That'll cause you to turn back right. So you're going to swim toward the target. what we're trying to do is get rid of that swim. And all you have to do is make the dead zone wide enough that when you fall inside of it, you stop turning. As we discussed one time a few weeks ago on my robots, because I use the rate limiters, once you're inside the dead zone, the little tiny corrections keep you there. But even in that case, as you got closer and closer to the waypoint, suddenly you'd be outside the dead zone. So the dead zone is not really, it's really there just to stop those oscillations. And what Scott was describing, I mean, lots of linear controllers use a dead zone so that you don't have oscillations in the middle. All servos do that.
Well,
And if you're using a proportional controller where you actually know the size of the error and you're using that instead, then the PID controller can damp out those oscillations. You don't need a dead zone. The dead zone, a linear controller with a dead zone is kind of a poor man's PID controller. And one of the reasons that they get used a lot is because they're so much easier to adjust than a PID controller.
so what's striking me though is not, I mean, I'm not arguing against a dead zone. I'm totally comfortable with, but what I wonder is that when you're at a point and you have a new waypoint, so you make basically a heading set point, right? So when you're at a certain point in time and you want to head to a head point, at that point you say, well, my new heading is in this direction. From where you are, the heading for the waypoint is over there, wherever there is, right? So as you continue to go, do you ever change the heading waypoint from the time you start moving toward the heading set point, from the time you start moving? So in other words, let's say the waypoint's over here where the corner of my door is, right? So I'm heading off, but I have a wide dead zone. That's fine. So I'm heading to the other corner. Well, when I'm here, the angle there is, well, I'm still within the dead zone here, but now the angle, the heading towards that corner is quite of a different set point than when I was here. You see what I'm saying?
Yeah.
Because I'm off the extended trajectory. So as long as you stay on the heading trajectory, then the heading set point is exactly what you want it to be. And if you're a little bits off of the heading set point, then who cares? But if you're a long distance and you're a little bit off, after a while, the assumption that the heading set point shouldn't change.
I think that may be the blocking point here. It's not like that you made a heading that you turn to a certain angle and then you just drive in a straight line along that angle. So let's go back to your example. Here's the robot and he's pointed that way, and I have a new waypoint here.
Yeah.
All right. So I'm running at 25 hertz. So that 40 milliseconds from now, I say, which way is the waypoint? Well, it's to the right of me. So I say, turn right for 40 milliseconds, and go forward.
Yep.
And then 40 milliseconds later, I say, where is the waypoint? Well, it's
Still there.
right of me. So
Yep.
turn right. All right. So what that means is that I'm going to continue turning like this until I'm pointing at the waypoint. Right?
Okay. All right. So that
Until I'm
answers
pointing
my
at the
question.
Once it falls inside the dead zone, the only corrections I make will be little bitty tiny ones to try to stay in the dead zone. Or if there's an obstacle I've got to go around, then once again, I'll have to do that same thing. I think
providing the dead zone is narrow enough, and I think you've helped me understand that mine was too wide, and so I wasn't applying any correction at all.
Well, do like Scott was recommending, just make the dead zone 0 and watch it oscillate, and then make it bigger until it stops oscillating.
Okay, will do.
But isn't the other variable then? And thanks for that explanation. That makes sense. But isn't the other variable in this though the gain on the heading correction? So if you move a sample and you have to change the heading, you only change a little bit. That's going to be different than if you change a lot, right? So that change on the heading correction as you move closer, you got the gain on the heading correction change and the width of the dead bone. Those two things together, I think, lead to this behavior you're talking about.
That could be, but I think in a generic sense, if the gain is too large for the turn, you're going to overshoot.
Well, then
And
you have oscillating on that way.
yeah, and that's not just with navigation. That's anytime you're trying to, steer in on a beacon or anything else. If the gain's too large, you're going to overshoot.
If it's too large, but then if it's too small,
It
you
just
have the
means
point,
it just means it'll take longer to get there.
and you may not have enough distance if the deadband's so wide, right? So the deadband and the gain work together, is what I'm saying.
Yes, and as I threw in, I also, because I slew those behaviors, if you can imagine, you're inside the dead zone, but you're not going straight down the middle of it. You're a little bit off to one side. So very, very slowly you creep over until you bump that side. So that sensor says you're now outside the dead zone. Because the correction slews, so let's say we're going to a correction of 50 and at a slew rate of 10. So the first time around you'll get 10, and the next time 20 and 30 and 40 and so forth. But it may be that 10 is enough to bump you back inside the dead zone. So you never actually make it to the full value of that hard turn. The little tiny corrections keep you inside the dead zone.
Hey, can I jump in for a sec?
Jump right in.
Okay. I had a question on this SparkFun part, and I saw something there that kind of, to me, said it was for automotive applications only.
This is the one that Scott put a link in the chat for. Thanks, Scott.
Yeah. In the calibration, this is in, what is it? Okay, Dead Reckoning overview. One of the things that I saw in this and the reason why I thought it was specifically for automotive applications is this line here. The car must reach a speed over 30 kilometers, which is like 18 3/4 miles per hour. So I thought my robot is never going to make that speed. So it's like close to 20 miles an hour. So I didn't think it was going to be usable for anything but something that went at least that fast.
It may not be.
Yeah.
No, but did it say for calibration purposes it has to reach the speed?
Yeah.
Or also for regular use? It sounded like that was under the heading of calibration.
Yeah, but does that imply you can't calibrate it unless your robot goes over 30 kilometers per hour?
No, so you put your robot in your car and then you drive around.
Yeah, but then when it's going below 30 kilometers per hour, will it actually work? I don't know.
Well,
And that's why I thought maybe that was strictly for, automotive applications.
Well, if this is for automotive applications, why doesn't it have a CAN bus?
Don't know. Maybe it wasn't intended to interface to CAN bus. Anyway, I saw that and I thought, okay, I don't know if that's a thing, where they tell you it's for automotive use, and you try to use it for something other than automotive or something. I don't know.
Your robot needs to go faster.
That's right. At least 20 miles an hour, 18.75 miles per hour. So.
Well, I was going to use it on that Pioneer platform, so it may go that fast. I'm not sure.
Could run that fast, yeah. Hey, Scott, I had a question. How much does your new robot platform weigh?
Which one? The Pioneer?
The one that I think that's on your desk behind you there?
The Burp here? It weighs about 28 pounds, I think it is.
Wow.
28, 29 pounds.
And it's 4-wheel drive?
Yeah.
Yeah. Okay.
So I'm still working on the LiDAR camera. I'm trying, using that much data has become very, very tricky. I've come up with the idea of using kind of windows so I can break down, because it's 160 by 60 pixels, and it's almost the same field of vision. So I've kind of set up a software window where I can define a window and then get specs out of the window where you're not looking at each individual pixel. So you would get specs from the window of like what the shortest pixel was and what the longest pixel is, what the average, and you can adjust the size of the window, to narrow down. And I'm just now starting to play with that to see how well it's going to work.
You talking about the Oak D Lite?
No, this is the CYG LiDAR 3D camera.
Oh, okay.
You know, Scott, that's kind of what Chris was doing with his LiDAR as well, breaking it up into segments.
Yeah. I mean, there's just so much data, you're just overwhelmed by it. You know, I'm running it on a Pi 4. You know, the serial port on it runs at 300 meg. So it's in each 3D packet is 3,800 16-bit. Or no, I'm sorry, it's 38 something 8-bit characters for the camera, because it's a whole packet structure plus the data. And then it has this goofy where 1 byte is part of the 16-bit value, and then you take the nibble out of the other byte and you shift it all over and flip it around, and it'd be a lot easier to use one of the libraries, but I'm not going that route.
It's TMI. Too much information coming at you.
Well, they also the software I got from you know, downloaded from GitHub, they're actually setting it up to map. So they do all these calculations based on the angle and the length. They calculate the linear value from the face of the camera, and then that becomes like part of the point cloud. So you get this 3D image of the, you know, the height and location of this point in 3D space. And all I'm really using it for is obstacle avoidance. So all I really care is there something closer to me than X, right? I'm not trying to really map the environment and do, you know, like a SLAM setup. So
right.
I kind of pared it down and simplified it, because like I said, I'm just using it for obstacles. So, and then, you know, I'm even narrowing it down from there into smaller windows so that you can really do something with it without some sort of network or, you know, neural net or some kind of calculations on it. You know, unless you're going to start doing the mapping, which I'm not there yet. Maybe one day.
So I posted in the chat the what I thought the unit I thought you were referring to, which is an RTK GPS unit, again for automobiles that has the IMU stuff and Fusion software in it. Is anyone here using the BN055, or is it good? Is it good? Is it easy to use?
I think so.
Yeah.
Okay.
I use it in just a relative thing, and it does really well. So basically, when you turn the thing on and power it up or reset it, basically that's your 0 degree. I tried using it on Turd in an absolute fashion, and didn't have a lot of luck with it drifting, or had problems with it drifting and not being accurate. That may have been my installation. I didn't have a lot of separation between it and the chassis. But I on my CAN robot, I use it for, you know, direction and you know, without the magnetometer, and it works really well.
Okay.
Scott, what that comes down to is the mode that you put it in. You sent me a note a couple of years ago about what that mode was. Do you remember off the top of your head? That might be useful information for him.
Well, there's a mode command for that, and it's an enumeration. I don't remember them off the top of my head, but basically you can turn off the magnetometer and just use the accelerometer. So you can put it in these different modes. They have like IMU mode. They have compass mode, I think it is. There's one. You just have to look at the data sheet. I don't remember off the top of my head. But yeah, you're right. There's different modes you can put it in. So you can kind of play around with what works for you, or what, you know, how you want to work it. I tried both modes on Turd, and like I said, I just stuck with when I just set the robot facing north, and then I turned it on, and that was my calibration routine, and it seemed to work pretty good. I mean, I did fairly well in that contest. It did a lot better than I thought it would. That's for sure.
Cool. Right. Well, let's jump around. So we have Steve joining us tonight. Welcome, Steve, if this is your first time. Steve put a question in the Slack, and if you're game, Steve, it would be great if you wanted to just brief introduce yourself, what you put in Slack, and talk about what you're trying to do, and let's see if we can give a hand. How does that work?
Actually, well, okay. My name is Steve. My daughter's nickname is Sandust. I'll just leave it as she's still a minor and she wants to get into robotics quite a bit.
Cool.
I'm a software developer by trade myself, and I'm normally called in to solve issues. And some of my stuff previously has been writing management software for robotics in the past. Has been one of my projects. So I've got some experience, but that was talking to a Galil board. And even then, I wasn't writing the Galil code. I was just writing the code to tell the Galil what to do. So when she decided that she wanted to learn how to do robotics and drones, I'm like, okay, no problem. Well, there's a little more to it. So we've been trying to figure out how to get this Arduino. We've been trying to figure out how to talk to this Arduino that I picked up a little while back. We've got some motor shields on it as well. We actually found the sample code and got it working tonight. Thank you, Rick. So, but if you have any links for, like, I guess to say the beginner crew, like any URLs or any places that are a good place to like read up and study. And other than that, we just wanted to make people's acquaintance and find out what's what.
Oh, cool. Well, welcome aboard. So there's probably a lot of resource that we have amongst the group. There's a really healthy number of years of experience between all of us in all kinds of different dimensions, and you'll find similar backgrounds: software engineers, hardware engineers, electrical engineers, active engineers, retired engineers, non-engineers. So we have all kinds here.
Works perfectly in real life. It doesn't.
But in terms of
we get tested often enough. That's why when there's a new war that pops up, both sides end up taking a bunch of new technology over there to loan it to somebody to get feedback on it and what's effective and what isn't.
Ed, are you talking to us or a different side thing?
No, I'm saying, on electronics and everything else, there's
All right.
you need a real environment to test it against.
Well, a lot of it, they tested it, and like that radio system.
No, it sounds like a sidebar conversation somewhere else.
I'm gonna mute you, Ed. I think you might be in a sidebar. So, okay, you can unmute yourself if you're hearing us. Otherwise, we'll assume you're in a sidebar. So Steve, I think the thing is that could you tell a little bit about your project? Because just like getting an Arduino to drive a robot is a pretty big topic. So are there
starting off as like a basic excuse me. We're looking at having a basic two-motor, or well, probably just a two-motor drive on a cat track with a Raspberry Pi, kind of controlling the Arduino, figuring out where it's supposed to go, and the Pi picking up remote control instructions.
Okay. So you want to try to do the Arduino for the low level stuff and Raspberry Pi for the higher level stuff.
Yeah.
Okay. Well, I'm going to jump in, having tried that, and others can jump in and agree or disagree. But in my experience, that's a high bar to set for a beginner, just because of the interprocessor communication. So I would suggest just picking one, whichever you want to start with for whatever reason, whether it's Arduino or Pi, and then start with a very simple, like hello world, single processor thing before you start worrying about multi-processor things.
That's okay. So what I just gave you was the end goal.
Okay.
Then we're doing the little baby steps first. And the first one that we got working tonight was actually computer talking to Arduino, making the LED flash, just like getting the code to upload.
Well, blinky
After that-
LEDs. We all start with that. That's
Yeah.
still start with
Blink
that.
LEDs is the basic starting point. It's also a fallback point when things.
Yeah,
The
I've already got a
LED is the hello world in
We-
the software.
Yeah,
We get a whiz bang new high end processor that needs a fan, and the first thing we do is blink the LED on it.
Yeah.
I've got a motor skill on the Arduino as well, and the next thing is we're going to actually start trying to figure out how to get the Arduino to control the motors.
So, do these motors have encoders? I mean, do you have like a kit that you're working from, or did you piecemeal it?
Pieces and parts from Tanners.
Oh, there.
And
You got
by the way, if you have a good
happy folks
replacement-
on the call. We are Tanner's aficionados, at least those of us in Dallas.
yeah, and if anybody knows a good replacement for Tanners,
We would all bless you.
Yes.
Yes.
Mark
Well,
Sims told me
it's
he,
not quite Tanner's, but there is a place I like to go to off of Beltline. It's called CDC Products. They got a lot of machining stuff, but they carry, the odd motor and some electrical stuff and some solder stuff, and just materials. I get like nylon. Basically, they have like shortcut stuff there. So, and the guy that runs and owns it, he's a really nice guy, and he'll help you out. It's got about every size drill bit you could ever think of. So it's like I said, it's not quite Tanner. It's not really electrical, but it's definitely a go-to place for me.
It's funny that you mentioned CDC. I went there about 2 years ago on Doug's suggestion, and there was a really nice face mill that fit basically the what you call it, the collets that I have on my Bridgeport mill, which are quick switch 300 series. So nobody makes it anymore. Nobody uses it anymore. But he had this really nice face mill that fit on there for $80. And I went back there like about a month ago, and it's still sitting there. So nobody bought it in 2 years. I think I'm just going to offer him $50. It's like, hey, I've been here 2 years ago. It's still sitting on your shelf. It's a really nice face mill, though. So
I wish Doug was here. Does because so on DPRG.com or DPRG.org, we do have a couple of tutorials that are relatively current and some projects which are not quite current but may be relevant. And then we have a YouTube channel as well with lots of videos, but I don't see anything that's quite aligned with roll your own motors and hardware and motor shield. Doug had a course that he gave, but he's not here tonight. I don't know if he's published it yet or not. But it was on very much that, starting with the very simple, basic robot and explaining the parts and the sensors and the actuators and how they work together, and then how to code it, how to get from very basic starts to a robot that can drive around and measure its ticks and avoid things. Anybody else have some ideas on where Steve might look for? I know Hackster.io has a lot of projects, but I haven't gone and tried to hunt for those lately.
Well, since I'm a Hackster ambassador, I haven't gone to look for those either. I'm terrible. No, they do have a lot of starter things out there. I would highly recommend perusing Hackster.io because there's a lot of beginner projects out there for all kinds of stuff.
I'm sorry, what's the name of that project?
Hackster.
I put a link in the chat, and if you type that link, it'll pull up some examples you might find useful.
Yep.
Awesome, gentlemen. Thank you.
Yeah. Yeah, and if you had like specific boards or schematics or things, we often pull those up and and share them for feedback from each other. So feel free to do that if you like. And if you'd rather we turn off the recording for whatever reason, when you want to raise that up, that's fine too. We do that at times. And there's some more examples coming in the Slack for you. So four examples for you. Maybe they help. Cool.
Yeah, Adafruit used to have a list of electronic suppliers, and I think that she may have included Tanner's at one point. I just looked around for it. I didn't see it, but it's like MPJA, Electronic Gold Mine, Herbach and Radman. There's All Electronics, Alltronics. They're all, stuff you can look at online. But they're, she had a pretty good list of them. But I haven't seen it in a while.
And that's another option too, right? As opposed to, it can be a little harder starting from scratch, pulling the pieces together yourself, just for whatever compatibility reasons. Sometimes it's easier to just go get like Doug used for his class, just get the $20 or $30
simple kit. Yeah.
Simple kit off of Amazon and get your feet wet with that. And then those can often give you a base and a platform to start hacking on and do more with it. So for example, Doug Dodgen is pulling one up now. It's a little more than the $20, I think, but maybe not that much.
There's also books. You can get, this is a pretty good one, Beginning C for Arduino. There's another one done by Jeremy Blum. I think it's Blum. Yeah, Blum. So probably anybody that's investigated Arduino, and probably more for a beginner, those books or the books like these are really useful, especially, I don't know how old your daughter is, but
they have books for every age range anyhow. So
yeah, these are things that she could, write a kit like Doug is showing. But these are books that, really start out from blinking the LED to, on up, and they're pretty useful.
My opinion is that by getting a kit, that one I was holding up, I think it was about $70, but it has all the parts, all the instructions. It teaches you the basics, and then you can go off and do your own piece by piece.
there's actually, I went and got one of these too. Now that we get onto this topic, I'm going to put a link in for one of the kits. It's a $73 kit on Amazon right now, and but it's made by MakeBlock. And what's cool is that it goes together really easily, really well. It's well made. It's hard to screw it up and short things out, and it's very extensible, and it uses Scratch. So if you're in the mode of wanting to get someone up to speed on basic programming concepts, Scratch is a really nice environment, and it works pretty well on this. I can tell you from firsthand experience helping cousins. So, okay. All right. Well, if there's nothing else, who else would like to jump in? What's next in queue for tonight?
No, just to address that again, there are a basic set of skills that you need to learn to build a robot, and it's sort of like scales and arpeggios learning to play a musical instrument. But you can go out and buy books on scales and arpeggios for any instrument. I'm not sure there is at least off the top of my head, there probably is out there somewhere, but there's a handful of basic skills, and it'd be useful to have a list of those. Like the first one is flash an LED, right? As discussed.
Yeah, and the next one will be push a button to turn the LED off and on.
Yeah, read an input,
Yep.
And you're going to have to deal somewhere along the line with RC pulse signals if you want to drive servos, and some of the motor controllers you use those. I think people in this group, or at least who go back far enough, built their own H bridges and wrote the whole program. Now you can buy one with a microprocessor that you can talk to at a high level. And but still, it's the same basic thing. You need to generate the same basic signals. And
Steve, if she knows Java already, then she's it'll be a very easy transition to C++, and Arduino is C++ based. So, she's 90% of the way there.
Huh. Yep, it's toast.
Yeah, too bad John Kay isn't here. I think he has every book on
He does.
on robotics and everything else for that matter.
He's
there was a
lecturer.
comment made earlier about it'd be better not to sort of get started on having the Pi talk to the Arduino, and I guess I'd have to agree with that. But it's a pick one, which is hard, right? Because the Pi doesn't do much I/O. I mean, you gotta still bolt a bunch of stuff onto the Pi, and not quite as, well, there are a lot of hats out there. I guess I'm not a big hat user with Pis, but it's easier, I guess, with Arduino to just find a hat and off you go. You got your motor driver now. But what I'm really getting at is the one advantage perhaps in picking the Pi. So if she's familiar with Java, I mean, one thing you can do on the Pi that you can't really do on the Arduino, at least not on the standard Arduinos, is you could use Python, which has a bit of a more rapid prototyping feel to it, right? There's things you can do in Python, and I'm still learning it, but I appreciate sort of the interactive nature. And you just type in a command and you see what happens right away. It's not something you can do in C or C++, right? And so that can have some benefits, right, in your workflow, and especially when you are trying to figure things out. So I just wanted to throw that out there. It's a question of, if she's not familiar with C++ or Python, and maybe C++ is an easier transition from Java, but maybe Python is just as easy for her to learn. And there's, again, a lot of rapid prototyping that can be done more easily, in Python. It's not, you can't shoot yourself in the foot as easily.
And you don't want to be initially overwhelmed. Even the simplest little robot that will move can generate some excitement. My father was an avid fly fisherman. When he first took my sons fly fishing, he took them down to a stocked pond. And I thought, well, that's not fly fishing. And he said to me, when you first go fish, first time you go fishing, the most important thing is to catch the fish. And I think that's the same here. If you start off with a fairly complex design, then, as people here, it could be years before you get a working robot.
Yeah. How many of us said, "Oh, I can do that in 3 months," and then 3 years later?
Yeah, that was Jack's transform. We'll call it Jack's transform.
Oh yeah, I've shown up to the annual contest here in Connecticut, and the thing wasn't really moving at all. Yeah, it happens.
So just to have a robot that you can turn it on and it moves is huge, and we reward that in this group. So,
Gold stars.
You get a gold
as I say,
star.
especially for a young person, the results are really important. Get something moving right off, even if it's clunky.
But I mean, the other thing to think about is, right, how much do you want to build from scratch versus how much do you want to just buy and use, right? Because there is a case to be made, right, for off-the-shelf kits that figure out some of the low-level nitty-gritty for you, and you can focus on something more abstract and type, you have a line of code that says move 10 inches, and it moves 10 inches, and you can sort of focus on some more interesting logic versus are you interested or is you not interested in really understanding and learning and what's going on underneath and how to put some of those building blocks together from scratch.
Yeah, to David's point is that getting something moving and doing active early on without getting bogged down with just using a kit to start with and then branching from there, I think is a good approach.
I know it's kind of ancient history now, but my boys and I began with Legos. And so the first thing you get moving, you get a little vehicle that you're all excited about, and you turn it loose and it runs into something. So here's a problem that has to be solved. What do we do when it runs into something? And basically all of the robotics grew from that.
Have you ever heard of random nerd tutorials? Can I grab a screen here?
Go for it, Ray.
Share. And where did it go? That's the website, Random Nerd Tutorials. And he has sections on just about everything. So like if you click on the Arduino, I'll go back one. There's the Arduino tab. He's got stuff, I've looked at him for ESP32 stuff and MicroPython stuff. Even the ESP32 CAM, he's got several things on that. But just under Arduino, there are tons of little modules, and one of the ones there is, if I can find it, guides. Okay, maybe I went past it. He had a thing on how to drive like DC motors, and so the tutorials are fairly short. He gives you code you can copy. It's free. If you really want to get into all the things that the Arduino can do, interfacing with LCDs. Where was that one? It even gets into more complicated things. These are, that's a cell phone module. Using the modules to send and receive SMS messages, things like that. I know there was one in here that was for how to drive a DC motor. Oh, there it is, Arduino DC Motor. So there are tons of things. It's free. He sells books. You can buy the books, but for things like this, you don't really need to. He pretty much has all the code. Let's see, where's a good one? Sensor. Okay, I'll click on that one. Yeah, there he's probably using, looks like an L293 or something. But, let's see, where is that one?
In that particular one, they are actually driving a straight H bridge and having to come up with all those signals, which most people don't do that anymore, except for some very small project.
Yep.
Ray,
He talks about, a robot car project. And then, you can get to that particular project by clicking that link. I'm going to click on robot car. So yeah, that's one of the cheap kits. I don't even think that one has encoders on the motors, which we strongly recommend that you get one that does, because you can do a lot more stuff with it.
With encoders. But I think that's the one isn't that very much like the one Doug was using in his class, right? So it's a good starter.
Actually, this one does have encoders, but I think they're on the wheel, and it's fairly low resolution. You can see them there in the package. But as opposed to the back of the motor, which you really want.
The Arduino?
Say that again.
Does that include the Arduino? Or is that separate?
I don't know if that kit includes an Arduino or not. I'd have to read the article. Smart Robot Chassis Kit. I think he tells you where to get it. Oh, I guess that one was from eBay.
Yeah, I think that was the one that's $22 or something like that.
It looks it, yeah. But anyway, so there's plenty of good references for a lot of stuff on his website, and he sells his stuff. But
Wanna wear this shirt on Friday, Thursday?
Yes,
Get up.
it's a wonderful shirt, babies.
I know. I'm trying to find.
Ray, I couldn't help but notice that you referred to that in a Freudian schlep as random nude tutorials.
whoops. Oh well.
That would be a dark website, right?
I always had clothes on when I looked at them. So
Well, I wasn't going to ask.
anyway, so that's a pretty good reference. If
Different kind of TMI. Different kind of TMI. We're not
Yeah,
overloaded.
yeah.
We're just overloaded with stuff we don't really want to see.
That's right.
All right, so who has robot targets for next week? If we're all kind of quiet with what we've done in the last week, are we just getting ready for St. Patty's Day? Or are we,
Yeah, that's it.
that's what it is?
Oh, looking forward to drinking green beer.
All right.
Well, on my, excuse me. On my stream, we've been doing some ROS 2 stuff.
Oh, yeah.
And learning some things of how it works and breaking things up in an object-oriented kind of way. I'm probably doing it all completely wrong as far as ROS is. I've already found out some things I shouldn't be doing, and I stopped doing them, like global configuration services and that kind of stuff, because that's not how they do that. That's not how ROS is designed. So I'm going against the grain. And I've got me a servo driver node. I wonder if I can show that. What I got going on.
Harold, since we have a Ross in the group now, I think we have agreed to refer to it as Chris does, as Roz, like with a Z. Roz.
Let me pull up my I'm sure you can see things in that kind of crap. If you want to pin me, it'll be a little bigger for you. I've been designing some stuff out, and I've started walking through and actually making some of this stuff happen on the stream. So there's the node layout.
So what kind of node, Harold, are you making? What kind of node?
Few different nodes. I got several different nodes going on. So here, what I'll show you. So this is the basic layout that I've been going for. Been starting down here at the bottom. I have a servo driver, and at some point I need a real motor driver, and that'll be another one down here. But the servo driver needs to know a few things like, you need to tell me what channel and what degree you want me to set this to, because that's how the driver currently works. Instead of sending I'm using the Adafruit drivers, so it asks for degree angles and that sort of stuff, as opposed to a PWM setting on that. And so I need, and I also need the nodes to subscribe to. So if you look at the second node here where it says node 0, node 1, node 2, that's node 0 through n minus 1 nodes. And each one of them will know how to grab its name and call itself the thing that it is. And since I'm on a rover, it will, in my setup file, I will call, in fact, let me show you that if I can here.
And could you make it a little bit bigger, Harold?
Yeah, I can try.
Is it just me who gets it very blurry? Maybe it's my internet. I mean, it's
It's illegible from my end.
It's a bit small, and my I don't have enough screen to show everybody everything that
it's
I
not
want.
just size. It's somehow it's blurry. Again, are you doing the thing where you're doing a camera thing, or are you sharing?
Yeah, he uses OBS Studio, so I think he's now I understand what I subjected you guys to. So I apologize for that.
No, well, I'm also doing something else here. I've got NDI running, so I'm taking an NDI feed and throwing it through the OBS Studio, and that's probably not helping things very much, because if I change the thing to me, right? Am I besides being old and that kind of stuff, do I
With
look basically clear?
With you pinned full screen, you look fuzzy.
I look
Yeah.
fuzzy.
Yeah,
But
it's
it's
not
hard to
nearly as clear as when you present.
it's hard to tell if it's the camera or the
Or the
encoding
subject,
decoding.
yeah. Or the subject. I got you. I understand, Carl.
Well, you said
Okay.
subject, not me, but
I know I did. I did. So I'm gonna see. So
it's
see if I
big
can-
enough though. We can see it
okay.
like that.
Go away, you. I don't need you now. So basically, at the bottom of this thing is actually interacting with hardware. I'm going to have a servo driver, and it takes a param, which is the node names of channels to subscribe to, and the number of channels I need to worry about. So if you tell me, you know, I'm on channel 27 and I only got 8 channels, I need to worry about that, right? And so these servo nodes here are the individual nodes. For instance, I call it servo node 0, 1, whatever. But when I'm implementing those things, let me go grab the config off of that. Source config. I have a servo. There's the servo driver, and you probably don't want that there. Don't want that there, and you want that here. And I'm going to say Control Alt equals, or just Control equals. I didn't ask you to do all that. Thank you very much. So I've got my servo. That's all that thing needs at hopefully anyways, is a number of servos and the various things we want to subscribe to. And that's left drive steer, right drive steer, right front middle back, front middle rear, and then left and right combinations on those two characters at the front. Well, I'm going to subscribe to those nodes. My naming, I'm not caught into the name too much right now, but I got those are the nodes. When it comes up, it will listen to those nodes. And so when I'm on the servo nodes right now, when they come up, I call them when I launch, I give them their specific name. So I can call the servo node n number of times and give it a different name every time I call it. So then I can look at my name. I can publish stuff using my name as a prefix for all the things I want to do. And then the parameters I care about, I get to pass those along for each and they can be different. So at some point I'm going to write some kind of Python. It's going to go through and it's going to ask me what the left front does and how far it can turn and all those sorts of things. So I've got min and max on my servos and I know where straight ahead is or neutral is. So it can set those sorts of things inside the node itself. So it cares about those things. And I only got 2 of them right now. And I'm still, this is where I'm up to working through what's going on. And I don't know if I need to do anything different for a continuous versus a standard, but I put it in there for a potential. This is what I'm going to have to deal with, right? So, back to the node layout again. Close that up. Give me my.
Because Harold, you have both standard and continuous on your XMI robot, don't you?
Yeah, I have both of those.
Yeah.
And I don't know exactly what I need to do differently on both of them. I may have to do something different. That may be a slightly different logic because I'm a continuous servo versus a standard servo.
Yeah.
And so I'm allowing for that possibility. And then the idea is these servo nodes will then I will also now give them who to subscribe to. And they're going to be my different modes. Now this math thing here, man, I don't know what to call these things yet because I'm just putting words in there. So I know what they want. I know what I want to do, but I'm not sure how to call them. And so the idea is that UI node's a different story over there. I just chunked it in for hell. But whether it's Ackerman, spin, crab, that kind of stuff. So the idea is this driver node here will figure out what kind of thing is going on. It will send a message or publish a message so that only one of these can actually do whatever I want it to do. And then this gets a little fuzzy up here because I don't know exactly all because I don't want to get into behavior, ballistics, and all that kind of thing. But the idea was that I would have some kind of behavior thing going along there, and as that thing figured out, this behavior node would figure out somehow have a priority somewhere in the way. I know you guys have discussed a lot of priorities, so I'm not even beginning to think about that. I just know that there has to be some stuff in there, and there's got to be somebody as a gatekeeper in there. And I believe that's what that's going to be. And when that thing figures out which behavior we need to have, it listens to the thing. It listens to the thing of the behavior. Like the navigation is in charge, or collision avoidance is in charge, or the human is controlling the joystick, and so he gets to be, or he or she gets to be awesomely in charge. That overrides everything, maybe, unless I want it. Well, even if I want to drive it over a cliff, what does a robot know? Anyway, and then what that does, that'll send some kind of direction or movement down to in the driver mode, and the driver says, "Oh, we want to move," and I'm taking the key off of every one of you guys have told me. I want to go at a heading and a velocity. I'm not an X, Y, and Z person. I'm not those kind of things. I'm doing a heading and a velocity, and then I let these Ackerman spin or whatever figure out what that means in their particular mode. Obviously, the spin mode can't go forward, so if you tell it to go forward, whatever, but it can certainly spin at a rate, right? That sort of thing. And that's how I'm kind of designing out a lot of this kind of stuff. I probably overthought most of it and that kind of thing, because I am being self-deprecating humor on all this. And all of these are all messages, all these are all topics. And if I've done what I think I need to do, this configuration, if I want to put this on a rover, I'll put it on a rover. If I want to put it on a two-wheeled drive buggy, I'll put it on a two-wheel drive buggy, then work through the configurations in it to be able to do all these things to tell. Because I mean, you think about it, there's only a few differences between my six-wheeled rover and your four-wheel front steering thing, right? Number of servos is one. How many? Because effectively the electronic speed control is nothing but a servo that doesn't really move. It switches power for you, and then you got a steering that goes left and right, right? We'll have to do something wacky with these other nodes up here. Of course, that'll take stuff for the different robots. But hopefully, when I get this kind of done, then I want to fire up a two-wheeled robot or a four-wheeled robot or whatever that is. I can use these bases and start stepping on top of myself and use that going forward. Kind of my idea. And we're building that up on my string, or whatever.
Harold, I can give you a little feedback. Maybe you already know these things on the servo versus continuous rotation servo. Yeah. They're all really designed, such that you feed it a pulse, and it compares that pulse to an internally generated pulse. And if it's larger than that pulse, it drives the servo full speed in one direction. If it's smaller, it drives it full speed in the other direction. There's a little dead band in the center, and there's actually a sort of a deceleration band very near the center. But normally you can't choose what speed it runs. You can only choose the direction
that it goes forward or back.
Yeah, and then the servo itself is driving a potentiometer, and that potentiometer controls the internally generated pulse. So basically, you're comparing the externally supplied pulse with the internally generated pulse, and you're driving the servo until those two match, till the internally generated one matches the requested one, at which pace it stops. So now you could write a library that converts that into degrees. Say I want to rotate through 17 degrees or something.
Yeah, I'm using the Adafruit library that does that very thing.
And in that case, what you're doing basically is you're selecting the magnitude of that error signal, and that controls where you're going to be. But for the robot to use an unbounded, that is an unconstrained servo that always can continuously rotate in the same direction, you have to control it in a slightly different way. And you don't really get to control it like you do with an H-bridge, where you get to choose the velocity of the output. Basically, they either run full speed or they're off. You can choose forward or backwards. As I said, there's a little bit of a band in the middle there where you can get it to run. If you're very close to the set point, you can get it to run close to full speed, but actually a little slower. So it is possible to get some variations in velocity there. But basically, so that really requires a different driver. And usually what happens in the continuous rotation servo, they've just removed the pot, and along with it, the little stop that would prevent
it keeps it from going. It keeps it from stopping up against something.
Right.
I got it. So maybe so in this idea, I mean, that's just so this is a naive representation of it. So the idea maybe means that I now have a I have a continuous servo driver right next to this one that listens to those same sorts of things and acts differently, like you're saying. And that, so I'm putting a lot of object-oriented junk into what I'm doing here, but I think it makes sense. At least it makes sense to me. I don't know that it makes sense to real robots in a real-world situation, and if I'm just trying to slam my OO stuff on top of, you know, am I overcomplicating it? You know, which I may be, and if I am, well, great.
Well, I think in that, if I understand what you're saying, in that case, the continuous rotation is just another one of those ellipses up there.
Mm-hmm.
And the fact that they both use the same kind of servo is coincidental almost.
Yes,
I
coincidental.
mean, you really have two different drivers, one that drives things that need to drive and one that can move things to a specific angle.
Oh, I'm making things too big. Yeah. That's kind of what I'm trying to show. And I'm trying to make it where I'm not trying to make ultimate flexibility, because that's just dumb too. I'm trying to make it where I can do things like, if I want to do another robot, I can put one of these on it and my Raspberry Pi on it, give me a couple of servo nodes, configure them a couple of things on a PWM board, and then I could be driving. I don't know if I could be driving in an evening, but pretty quickly with the
minutes.
sort of things.
Just
Yeah.
minutes.
Yeah. That's kind of where I'm going to. Just minutes.
4 weeks to set up, and it's only minutes to turn it on.
Yeah, exactly. I mean, I'm thinking about all the things that we do, right?
Yeah.
The robot that's going to have a chance of winning in the Columbus thing, in reality, is a much different robot that's going to have a chance of winning the line following, and is way different than the robot that's going to have a chance of winning the can. Well, I would suspect them to be different. They could be all the same robot, but I think that's really, that general purpose nature of that thing is reaching a bunch, right?
Carl, to answer your question, Ross's daughter was swimming back and forth across the screen, so I was actually just offering that for her so that she wouldn't be bored.
Oh, I see. Well, you caught my attention too. And speaking of Ross, I think so David was trying to get your daughter's attention with Barack, the space ghost.
Oh,
I think Jim was
didn't
trying to
see
get
that.
your
I had
attention
it pinned
with
on
something else.
the other one.
But anyway,
Jim is trying to get your attention, Ross. But oh, sorry, Harold. What were you saying?
No.
Ross, are you there?
Yes.
Please check your email.
Yes, I did. I just replied. Thanks.
Okay, thanks. Gotcha. Okay, thank you. That's all. Thanks.
All good.
Yeah, Jim raised his hand there. Was that Jim?
Yeah,
it was.
Yep. Just closing loops here.
Yeah. But I know it sounds complicated, but one, I'm having a lot of fun figuring this out. Ross itself, as we all know, is a very complicated, very feature-rich, as people like to say, system. And I must have spent a couple of hours Friday night looking for documentation on one of the things to say, how do you get the damn name of the thing I'm running on? That should be a pretty simple thing. And so after I found it, I'm like, oh, no big deal. Now here's a link, and I put it in. I put it in the README, and somebody said, you should blog that out, because I couldn't find it either. Somebody else will know, because we were all looking for it. I probably had a half a dozen people looking for it on Friday night.
Isn't that how it goes?
Mm-hmm.
I spent 2 or 3 hours today trying to get SSH keys to work with Bitbucket and VS Code on Windows, and I finally got it to work, but I'd have to use like Git bash every time I wanted to open it. So at that point, I figured out that there was another way to get an app password, and boom, it's done.
You know, that's another beef of mine too. They get up and they say, well, you got to have a PAT, a public access token now, not just a normal password. And if you go look at what a public access token is, it's nothing more than a really long password that they made up.
Yeah. It's the same thing. There's another gripe like that, right? So all these two-factor authentications now, they're going from text message to email. So you have to like log in and says, oh, we've sent this magic code to your email. So you have to go over the email and copy paste. Come on.
Or one of the 27 authenticator apps I have on my phone right now, because they all want to use a different one.
Okay.
So do
Yeah,
any of y'all
I'm whining now. I'm whining now.
does any of y'all carry a dongle in your pocket?
Not anymore. Or at least not in certain states where I got. Never mind.
Back
That was in the
the
Midwest state.
I had one. Well, I actually had a fancy one where you would get a code and you put that code into it, and then it would give you another code that you would send back.
Yeah.
Yeah, that's actually what we had in the late 90s at Nokia, in early 2000s.
Yeah, they had that at TI, I think it was, in the late
The RSA. Those are.
Yeah. The first one of those I actually had to use was you had a pager, and it had a rotating number every minute or every 30 seconds. And when you logged into a particular service, you had to enter in your prefix password that only you knew, plus that number that just randomly gets changed all the time. So that's the first one of those I used, anyways. Had to use.
All right. So what else is on the list for tonight? Any other?
You know, I noticed. I guess Steve had to check out, but it occurred to me that Ross is already along the path that he's talking about going down. Doesn't it sound like?
Myself, yeah, I'm going getting the serial connection set up to the ROS OS. ROS 2 installed on my Ubuntu laptop, so been going through the tutorials and with the turtle sim and what have you and that. So I'm kind of approaching it from two angles. I had an interesting experience though. I was trying to get PID working to get a steady speed and get my both wheels turning the same rotation rate. This is using the LMX code that I had, and I was reminded of something that I heard you say, David, one time in a talk that said that you should measure the, pay close attention to the stall current on your motors, because basically the resistance that you get there while they're at rest and the Ohm's law and what have you. And I thought, yeah, okay, well, it's kind of, you check the stall current and what have you and make sure it's good with your H-bridge and that. But I didn't realize that when I was doing the PID controlling, that anytime I called it to stop, it would stop, and I was tuning it. But I didn't realize at the time that when it was stopping, it was fighting its position instead of just killing power to the motor that I had originally had. And I thought I was actually using my stop routine, which was just putting both, everything low, but it was using the PID loop stop. And it sat there for a few seconds, and all of a sudden I heard this loud pop, and the room was all stinky. And
oh no!
So one H-bridge controller later, $8 lesson, which is fine, it's good. But the real fun began because this is like a plug and play controller part, right? And I had another one on hand, pins already soldered on. So I pulled the top off, pulled that one out, laughed at myself, plugged it in, changed some code. And that's when the real fun started, because then nothing would work right after that. Randomly, just the same code, pull the part out, pull the other part in. And, I ran a simple motor test. One motor would work, the other motor wouldn't work, and then vice versa. And sometimes it would reverse, and sometimes and it was just all over the map. And I hadn't changed anything at all, and I couldn't figure it out. And what it boiled down to, eventually figured it out, is all the moving around. And again, I had a bad wire a little while ago. I had a series of bad wires, and it just coincidentally happened that whenever I pulled it all apart to change the H bridge, I had another series of bad wires. So I remember I kind of had it all kind of put together as almost breadboardy type, the big mash of wires. I had them kind of nicely collected. I ripped all the wires out of it, and I said, I'm banning non-essential wires. Anything that can be done local is going to be soldered in locally. So I put a shield on top of it and put the the Bluetooth and the H bridge is on the shield and everything like that. So now I've got minimal amount of wires, and the sensors, anything that's on the periphery of the bot has some wires going to it, but that's all like solid core telephone station wire now. So
Well, you say that was a coincidence, but it's not. There's some universal law of physics that actually guarantees that those things all happen at the same time.
yeah, it is. It's has something to do with entropy and that rule of taking things apart and putting them back together. You'll eventually have two of them, kind of thing. So
For sure. That I just posted a video, by the way, link to a YouTube channel. His name is Lou Amadillo, and he calls himself the Poly Hobbyist on YouTube, and he's a program manager from Microsoft that does ROS 1 and ROS 2, and they are now the owner of the ROS extension for VS Code, and he's got a series of video, about 9 of them so far up there, about how to use it, go into it, and he's now he just posted one up on containers, and which is kind of cool because I've got all my ROS stuff on my Linux box on my Raspberry Pi running in a container. So I sit on my laptop over here and I SSH into my Ubuntu, then attach the container and do all the code work in that container. And since I've got all the code mounted as volume down there, I saved it all off to the local Git repository and I check it all in. But yet all my raw stuff runs in its own container doing its own thing. It's pretty cool, a little convoluted, but it's pretty cool. And he's got a video, just put it out, I don't know, sometime today. He's supposed to go on vacation. Trying to meet with him before he went for a 3-week vacation, and well, I didn't get that happen. But he's supposed to go on vacation, and he's still posting videos a day. I think he's leaving tomorrow or something. I'm like, you're an animal, man. So anyway, you might want to check those out. Those videos aren't very long. They're like 8-10 minutes a piece, and he's a nice guy. He's been here. He came to our meetup once and gave us a pretty good presentation. I thought it was anyway.
Oh, the same guy. Yeah, we enjoyed that.
Same guy.
Carl, I see somebody has their hand up.
I missed it. Who has their hand up?
Jim.
I think that was a while ago.
Oh, I'm good. Thanks.
Hey, Harold, did you know anybody at BG Micro? Did you have some association with them, or?
Not that I know of, no.
Oh, okay.
Not that I know of.
Yeah, I just looked. It seems like they're gone. They went the way of Tanners.
Oh, sad. I did post in a local job. I say a local, sort of local job rec up to DPRG. I hope I didn't violate any rules or anything on that thing. It just seems like something that somebody in this group may be able to do, and of interest, that kind of thing. So
I haven't heard of any trouble.
Okay.
Hopefully you get some feedback.
Well, there's one person that has sent me some feedback through my Twitch stream. He's a Twitch streamer I know, and he does a lot of this kind of work, and he has to be looking for a new gig. So hopefully we can hook him up with somebody doing something interesting.
Good deal.
That's all transparency. You folks are some of the most interesting folks I know, and that looked like a laundry list of very interesting things to be able to do. And so I thought I would share to see if anybody was interested.
Ray, we lost Tanners and BG Micro, and basically Mike's Hobby, which is where I bought lots of robot parts, Aero Hobby. This was all basically coincident with the pandemic, whether or not it was related. But basically, in one fell swoop, all those places that my robots are built out of are gone. And Mark Sims was complaining about, he said he was having Tanner withdrawals because when he wants to problem solve, he would go down and wander around at Tanner's, and I know exactly what he's talking about. And so basically, I haven't done anything since then. I'm a ship adrift.
That's worse than Tanner withdrawal.
I can probably
Yeah, my
accept
thing
part
was
of
like,
the responsibility for
Go to
that.
Tanners and look for a good idea.
That happened about the time I started getting interested, so it's probably my fault they all went away.
I got
All
no
right.
place to go.
Thank you for accepting responsibility.
Yeah, supposedly BG Micro bought a lot of Tanner's excess inventory, but I didn't see where, I didn't see any of it advertised or, granted, it's been a while now, but I don't know. It seemed like they disappeared about the same time, Tanner's did.
Well, and as you well know, it wasn't just their inventory, it was the constant process, ongoing process, where you never could tell what you'd walk in there and find.
Mhm.
And, I can search up those parts on the net and buy them and get them delivered to my front doorstep tomorrow. So, I mean, it's not that I'm totally cut off, but the problem solving part is really, really missed.
So is it just like the physical experience thing then? Is it really just wandering around in the, I won't say little shop of horrors, but the little shop of toys that
Well, yeah, you go walk
Yeah,
in.
you never know it's going to show up.
Yeah, I have this problem I'm going to solve. And maybe I have a couple other problems I've forgotten about. And I'm walking up and down the aisles looking at stuff and, oh, look, what is this? I could cut that tab off and drill a hole here and it would exactly solve my problem. I didn't even know what this thing is, Or, walk around and what were we paying for resistors? It was like 2 cents a piece for resistor. You walk up there and I'd have a double hand load of components and it'd be $4.13, So I buy things I didn't need. This room is full of them.
Yep.
You
Wire
found a
by
lot
the
of
foot, heat
solutions
shrink
to problems you didn't know you had.
Well, yeah, exactly. Or the other way around. Say, oh, look at this. That problem I'd totally forgotten about. Looks like somebody else has already solved it. It's a funny thing here with this in the middle.
So do we need to get you the garage tour? Like they have the garden home tour, you'd have the garage tour, and we just give you so you can go from place to place and you can clean out our garages and move them into yours.
I've seen your garages. I know they take years to clean out.
But think of all the problems you could solve by what you might find.
I think I'm just going to sulk in the corner and feel sorry for myself. That's my plan.
All right, fair enough. Okay, so what else do we have on tap for tonight? Are we running dry, or are there any more topics we should find for the evening?
Oh, I wondered, there's always that one of our next president. We, have any interest out there? And
are you stepping up? Right.
1, 2, 3,
No.
not it. 1, 2, 3, not it.
I nominate Ray.
No,
David
sorry.
is muted right now.
I have a suggestion. Suppose that we change the bylaws and we get rid of the office of president. I'm not saying this as a joke. And we replace it instead with an office that basically is in charge of running these Zoom meetings, and that's all. And all the other tasks are taken care of by the other elected members. That's kind of how it's done anyway. So as I thought through it, what that would leave out would be the planning of the contests. And many robot groups handle that by having a specific contest planning committee. That's their only responsibility. But since it's been so hard for us to get a president, maybe we just get rid of that position.
Okay, let's take that. So who would sign up to be the newly created person of running the Zoom meetings or whatever?
I nominate John.
John.
Look at everybody hide their cameras at that exact moment.
I nominate John because he's not here.
That's how it goes.
Although Carl's pretty good at that. So,
Well, thank you, but yeah.
Yeah, he's got experience and everything. I
Yep.
think,
Man,
yeah.
Yep. He'd be like a shoe-in,
yeah.
shoe-in candidate.
Boy, that makes it easy. And even if I'm on here, I can't defend myself. That's the worst. Well, I mean, all options are on the table, but that's where we are at the moment. No one's just jumping out of the woodwork. So
Well, I was trying to come up with an arrangement that would relieve you of the responsibilities which you have graciously shouldered here to shepherd this group of slackers.
I appreciate it. Even for running the Zoom. I mean, anyone's welcome to stand up and do it. But yeah, just reach out to me. I'll be happy to help you get going. But until then,
All right, Ray, I think you successfully killed the meeting.
That wasn't the intent.
that's all right. Well, we'll see what happens now that the daylight savings time is formal and we're stuck on this mode for a while, apparently. So that's all right. Well, gentlemen, all I can say is that been an interesting evening. It's very good. If there's nothing else, I would propose we rejoin again next Tuesday night and start your cheering pom-poms for Jesse Brockman's contest. All right.
I'll second that.
Yeah, there you
Take
go.
care, guys. Good night.
Night.
Thanks so much, gentlemen.